In this video we're going to have a look at factorising difference of perfect squares using surds. In the last video we had a look at the difference of perfect square formula, and I've just rewritten it here just so we can remember what it is. A squared minus b squared is equal to a plus b, a minus b. So this is our formula that we're going to use to be able to apply to these questions. Let's say we've got a squared minus 10. Now in the last video we said, alright, let's convert 10 to a perfect square. Alright, however, we should note that 10 is not a perfect square. Okay, because we can't actually just write it as, something squared. We need to do a little bit more work before we do that. Just on the side, I'm going to take the number 10. And basically what I want to do is get something to be able to square it, but the answer is still 10. So what can I do to 10 that when I square it, it's still going to be 10? And the answer is basically taking the square root. Alright, because the square root of something squared, essentially the square root and the square cancel each other out. It doesn't affect the number inside if you're doing it at the same time. So here, where I have x squared minus 10, I'm actually going to have minus the square root of 10 all squared. Now I'm able to do that because this has no effect. Squaring the square root, okay, cancel each other out. But it helps me because I now have a difference of two perfect squares. Alright, so I've got an a squared minus a b squared. So a squared is my x squared term, so a must be equal to x. And I've also got a b squared term is the square root of 10 all squared, so then b must be equal to what's inside the brackets. It's just the square root of 10. So when I go to my formula, I've got a, which is x, plus b, which is the square root of 10, and then a again, which is x, minus the square root of 10. Alright, so that's how I factorise these difference of perfect squares, but when this number isn't actually a squared number. Alright, let's have another example. Let's say we've got x squared minus 24. Alright, so just again on the side, I'm going to take the number 24 because I know that's not a perfect square. I can't just write it as something squared without doing some work first. What I'm actually going to do is take the square root of 24 and then square it. And if I do that, just remember, if I'm taking the square root of 24, alright, I can split it up into two factors, alright, 4 and 6. And the reason I do that is because I can get the square root of 4 times the square root of 6, and the square root of 4 is 2. So I'm simplifying the surd. Now all of this is still being squared, so I'm just going to put those back in. Alright, so instead of just the square root of 24, I've actually simplified it as 2 root 6 squared. Now all of these steps you can actually do in your calculations here. I like to do it on the side just so it's all ready to go and put straight into the equation. Alright, so instead of x squared take 24, I've now got x squared minus 2 root 6 squared. Alright, and then I think to myself I've got a squared minus a b squared. So a squared is the x squared term, so a by itself must be just x, and then the b squared term is the 2 root 6 all squared, so b must be equal to 2 root 6. So now that I've got those, I can put my brackets in. I've got x plus b, which is 2 root 6, a, which is x, minus b, which is 2 root 6. Alright, so that's factorised, and again we've just used some surds and simplifying those down. One more example. Let's say we've got x minus 1 squared minus 5. Alright, so first step, I just take this 5 and say, alright, what do we need to do to it? I'm going to say 5, make it the square root, and then square it. So this is equivalent to x minus 1 squared minus the square root of 5 squared. And then I say, okay, my my a term, a squared is x take 1 squared, and the b squared term is the minus the square root of 5 squared. A squared is just the x take 1 all squared, so a must be just x take 1, and my b squared term is the square root of 5 squared, so b must be equal to just the square root of 5. So when I factorise it, I've got a, which is x take 1, plus b, which is the square root of 5, x take 1 again for a, minus the square root of 5 for b. Alright, and that's factorised. I can't really do anything with these two because they're not like terms, so I leave my answer as a factor of surds, with surds in it.